Here we write the equation of the hyperbola given the graph of the hyperbola. From the graph of the hyperbola, we see that the transverse axis lies on the x-axis. This basically is the transverse axis. And we also see that the vertices are, this one is 3 comma 0, and this one is negative 3 comma 0. That is, the vertices of this hyperbola is given by plus or minus a comma 0, which is we determined as 3 comma 0 and negative 3 comma 0. So therefore we see that a equals 3. We also see that the foci is at 5 comma 0. That is, this distance is c, and c is given by 5 comma 0. Therefore we see that c equals 5. We also use the relation to determine the value of b, that is c squared equals a squared plus b squared. From that we solve for b, that is b equal to c squared minus a squared, we take the square root. So let's find the b using the value of c and a. C equals 5, so if we plug it into this equation we get 5 squared minus a equals 3, so it is 3 squared, and so this gives square root of 5 squared is 25 minus 3 squared is 9, and 25 minus 9 is root 16. So we take the square root of 16, which is plus or minus 4. So we have determined that b equals plus or minus 4, and so therefore the co-vertices are 0 plus or minus b, that is 0 comma 4 and 0 comma negative 4. And for this type of hyperbola, we can write down its general equation. uh, this hyperbola has center at origin. This one is the center. So therefore we write down like x squared divided by a squared. We put this a below x squared because the transverse axis is on the x-axis, minus y squared divided by b squared, and this equals 1. Let's substitute the value of a and b. A equals 3 and b equals 4. And so when we do that, we get x squared by 3 squared minus y squared by b is 4, which is 4 squared equal to 1. And so this is 3. I can just write down clearly. This is 3 and 3 squared. And so x squared by 3 squared is 9 minus y squared by 4 squared equals 16. And this equals 1. And so therefore this is the equation of the parabola given the graph of the, I'm sorry, is the equation of the hyperbola given its graph.